All right, welcome back to Algebra 2. Today we are looking at 6.6 and solving radical equations. So again, to start off, let's do a quick warm-up and go ahead and pause the video, see what you can do here. All right, so number one, this is to evaluate without a calculator. So 64 to the 2/3. What we have to remember here is with these are rational exponents. So we can think of, we can rewrite this expression because the bottom number of this exponent is going to indicate a cube root. Since it's raised to the 2/3, we can write this as a cube root of 64, and then that whole thing being squared. So we can rewrite this in nth root form by writing it like this. So now we can think about what is the cube root of 64. Well, the cube root of 64 is 4. So therefore this equals 4. So the cube root of 64 is 4. Right? Well, that number is then still squared. So 4 squared is 16. We look at number 2. The bottom number, the denominator of that rational exponent is a 5. So this could be rewritten as a negative 32, a fifth root of negative 32, and then that whole thing being squared. Well, the fifth root of negative 32 is negative 2. So this is negative 2. That becomes, and then that whole thing is squared, and of course that would be 4. All right, number 3 just says to expand x minus 5 squared. That means to take this and say x minus 5 times x minus 5 again. Well, that would equal x squared minus 5x, and then plus 25. So this would be x squared minus 10x plus 25. And then last one in the warm-up, solve this equation. This is a quadratic equation, so therefore we are going to put it into standard form, making everything equal 0. So I'm going to subtract x and subtract 45 to get this over to the other side. So subtract x, subtract 45. This will then become x squared plus 5x minus 36 equals 0. And then we can solve the quadratic either by factoring it and using the zero product, or we could use a quadratic formula. So this one I want to look to see if I can factor this because it looks like it could be factored. And indeed it can. So if I use my 2 parentheses, I think about what multiplies up to negative 36 and adds up to 5. Right? Well, that's going to be 9 and 4. So 9 and 4. And one of those has to be negative, so 9 and negative 4 would add up to 5. So this factors to x plus 9, x minus 4. And then if I solve that, my answers would then become x equals negative 9 and x equals 4. All right, so to get into today's lesson, we're solving radical equations. I want to look at a vertical leap or hang time equation, which is a very simple equation that is written like this. T equals 0.5 times root h. T is your hang time, or if someone were to jump, how long they would be in the air, and then h would be how high you actually jumped in feet. So if we, let's say we knew someone's hang time, how long they were in the air, we should be able to figure out what their vertical is. So for a little inspiration, we're going to watch a little bit of the 1988 dunk contest. between Jordan and Dominique Wilkins. Just for fun here, two of the all-time greats.
And slam dunk competition. And what LeBron is missing out by not competing in the slam dunk contest, Jordan capitalized on those iconic images that keep him young forever and will also sell those shoes forever.
For sure. Maybe LeBron just needs some competition, someone to go dunk for dunk with, to bring out the best in him. MJ had that on that.
It does. The music, too.
I do. That takes you back, don't it?
It does.
Michael Jordan, your defending champ from the '87 dunk contest in Seattle. Oh, and there he goes. Baseline, the reverse. 47.
Okay, I'll take the Neek dunks, and he just goes 360 tomahawk hard. And look at that. Again, these beautiful slow-mo camera shots. LeBron, this is why you have to dunk. So Wilkins beat Jordan the first round.
All right,
both advance to semis.
Yeah, wipe the slates clean. Jordan eyeing the free throw line. Some inspiration from an NBA icon.
I found the guy who started it all. Dr. J was sitting over there. He was looking at me, and he pointed, like going back and do the free throw line.
So he did that like spur of the moment. This wasn't a planned thing like it is now. He just went back and did his thing. More than 75 feet.
Just a little over the line.
Shucks, man. I can't do it.
All right, so he gets his 50. What does Dominique do? I mean, people didn't do that back then. That was awe-inspiring. I mean, he's so tall, so powerful, so long. Oh, my. Windmill dunk. So Jordan outscores him in the semis. 145, 143. We go to the finals. In the finals, Wilkins' first dunk. Here he comes. Backboard, high off the backboard, finishing hard.
Oh, my goodness, look at how high he got.
Again, they all look better in slow-mo. Above the square. And then throws it down. That's a 50.
All right, next is Jordan. The reverse again with the pump, and Wilkins is like, what? What?
Well, of course, Michael had the home court advantage. Dominique had to do everything. Baseline windmill. Another 50.
Jordan's second try. I don't know what you call that, but he just rocked everything. He only got a 47. The fans are like, boo!
So Dominique can win it with a 48. Windmill, two hands this time. And I guess between the boos and the two hands, it wasn't good enough.
No.
Just a 45.
Yeah, Mike gets a 49 to win, so I'm going free throw line again. Hey, you know he's home, so that's a 50 right there. The legs just wiggling. 147, 145. Jordan beats Wilkins. And the judges allowed to leave Chicago unharmed, I guess.
And that's where the Air Jordan symbol pretty much born, right?
There you go.
All right, so back to our vertical leap hang time equation. So as long as we know what the time is or how long someone was in the air, so let's say that the hang time, and we could like look this up, but I know that a human being can't jump or stay in the air longer than, I think, 1 second. So it might seem like it should be more than a second, but I think that's the maximum or pretty close to it. So I'm just going to put in a number here. I bet that Michael Jordan's, some of his hang times are close to 1 second, but not quite there. So I'm just going to guess. Let's just say he was in the air 0.95 or something like that. So let's say that 0.95 seconds is the hang time. And now we have this right here. And so if we know the hang time right here, and now we want to figure out, well, how high in feet is that jump, right? How, what's that vertical leap? So how would you solve this equation? That's what we're kind of looking at today. How do we solve this radical equation? And if we are to do that, we really just isolate this radical right here. So if we were to divide by 0.5, we get 0.95 divided by 0.5. It's about 1.9. So 1.9 equals root h. How do I get h by itself? We use inverse operations and we square both sides. And we get h is about So 1.9 squared is 3.61. So 3.61. If the hang time was 0.95, then that vertical leap would be 3.61, and that's in feet. So if I wanted inches and I multiply that by 12, that would be equivalent to a 43.32 inches there. So those are the types of equations that we're working with today. A simple little hang time vertical leap relationship here. If you've ever used those just jump mats in the gym, that's basically what it's doing, or a large portion of it is calculating how long that you're in the air, and it's figuring out what your vertical is based on that. So